I wanted to talk about the firmware and what that actually looks like. So I've got it loaded here. This is obviously the new firmware, which is version 022, and it's been basically, most of it's completely new. Let's have a look at the config files. You can configure the device as an access point by enabling the controller mode as access point, and you enable it by removing the two things like that. And I'll just put those back in. So in this particular case, I've got it configured as a station. It's going to connect to my own Wi-Fi network. It's going to be receiving a dynamic IP from the access point, and I'm using a special file which is called Wi-Fi config.json to provide the login credentials for the Wi-Fi connection. I'm running a management server, TCP/IP server and web server. Don't have any sensors attached. If you want to enable ESPNOW, then you would enable it here by removing the two leading slashes, the MQTT, the OTA, and web query. And so all those services or features options can be enabled or disabled here in the controller config file. And the other thing you need to note is that if I was, for example, to enable ESPNOW, it tells you here that there are additional parameters that you need to look at, and those parameters are stored, here it is, in the defines folder. So if I was to have a look at ESPNOW, these are the settings that you would need to change if you were going to send something other than various properties different from the relay states or the pin states, etc. There are two portions here. There's one for outgoing messages, which you would send to myESP Plus controller, and the other one is for incoming messages. In other words, some device out there can actually send us an ESP message telling us to change the relay state or change the state of a particular pin. So those messages could arrive into this controller and be acted upon. Yeah, so that's the file ESPNOW defines, and you'll note also that in that defines folder there's a whole lot of other defines as well. So for example, if you were wanting to run this as an access point, you would edit this particular file called soft AP, and if you were running as a station, you would then put these particular details in as well. Okay, so you need to check to make sure that the actual defines for each particular option that you choose is correctly modified. Right, so that's the particular firmware. Everything's broken up into various classes, etc. And a lot of work has gone into this to try and make it easy to understand, easy to configure. Right, you'll note here that I'm using Arduino 1819 and not the latest version, and the reason for that is that when you program this controller for the very first time, and subsequent times if you aren't running elegant OTA, then you have to upload all these special data files, and these data files are sitting in a folder called data. So there's a data folder, and all these files here manage the web server and management server, etc. And they have to be uploaded into the controller in order for the web server and management server to actually work. So there's a special tool to do this, and this tool, and it's covered in the PDF, this tool is called the ESP32 Sketch Data Upload, and so you install that, and then you can actually upload those special data files. You can't do that in Arduino 2.0, etc., because that's not supported. So you could only program the controller, but the problem then is because all those data files don't exist, the controller won't boot up properly. It'll recognise that those files aren't there, and it'll just go into a continuous reboot cycle. So every time you upload new firmware, you generally also have to upload all the data files associated with it, because there could be changes in some of the data files, so they need to be uploaded as well. And once you do that, it will be fine. Right, so here we are. This is the new Windows application, and I'm on the connection tab. If I specify the TCP/IP address of the controller and the port number on the TCP/IP server running on the controller uses 2020. So if I connect, away it goes. You can see it's connected. Here's the various relays. We can enable and disable them just like this. We've got various I/O pins. The I/O pins are arranged as pin 1 to pin 4. Logic state, enable state, so we can disable a pin just like that. We can change its power on and off state, and if the pin's disabled, we can also change the direction state. So I've changed this now to an input. The text on the buttons describes what the state will be if you click on it. So if I click on this, I would expect the direction state to go to output, which it does. For the relays, you've got relays 1 and 2, and again you've got a familiar logic state, enable state, power on state. And the power on state you can actually change regardless of what these settings for logic and enable are. Same thing applies to the pins. MQTT, it was not enabled in the firmware, so I can't stop and start it, etc. Various services, it tells me that ESPNOW stopped, Red Query is stopped, and the reason why they're stopped is because of the fact that neither were enabled in the firmware. But I've got the web server running, and I can stop that if I want, or I can start it. And the receive enable, send enable apply to the ESPNOW, and of course the connection box we've already talked about. The settings basically only, you have the reset log file path. If you want to enable logging, you just click this log errors button, and that's the Windows app. Right, this is the Linux I'm running now. I'm running it in a VM, and I've got all the source files here, and I'll just quickly show you. I'll run Lazarus, which is free, and the links are provided. Let me just make sure I'm using the correct one. So I'll close the current project, and the one that I'll open should be sitting on the desktop, so it's my username, desktop, etc, etc, and I'll click on the LPI file and open that in Lazarus. So this is what it looks like in Lazarus. Here's the actual application. Let's compile and run this. So away we go. So this is the application compiled and ready for us to use. I'll minimize Lazarus now, get it out of the way. And I know that this is the correct TCP/IP address for the controller, and the port I want to speak to is the TCP/IP server running on that controller. So I'll click connect. It tells me it's connected, and it's got all the values, and MQTT, as you can see, is not running, and so on, and various services. Let's get these to update them, and it tells me that the web server is running. I'm not running ESPNOW, and I'm not running web query. So all this is working. I'm actually logging controller messages. I have logging enabled, and the log file, which you can set the folder when you first start this, is in home Roberto logs, etc. So home home Roberto logs. There it is. And I have a folder for this, and it's telling me this was created right now, today, and so this is the actual log file, which you can use for debugging purposes or, for reference. So that's the actual application, and of course we can open a web browser on this, and we can specify the address of the controller. So let's do that, and it's 172, and so this is the web page, and we can also access the management server, which is on port 6060. Oh, one too many. And there we go, and of course it will ask for the username and password, and we know what that is, so we'll just sign in, and here's the management server. So you can see that I've got full access from a Linux system as well.